All right, we're going to identify key features of graphs. So we're just going to start out with some definitions that you need to know before you get to the actual graphs. So domain just represents all the x values. Range would be the y values included in your graph. X-intercept. So this is the point where a graph goes through the x-axis. So there can be more than one x-intercept. So it's at every single point where your graph goes through the x-axis. Same with the y-intercept. There can be more than one of these. It's the point or points where a graph goes through the y-axis. Increasing behavior, where the graph is increasing, so going up, when you're reading it from left to right. So just like you read a book from left to right, when you're reading your graph, you're going to also look at it moving left to right. So anywhere your graph is going up, going left to right would be increasing behavior. Then we have decreasing behavior, where the graph is decreasing or going down when reading it from left to right. So as you're going left to right, anywhere where your graph goes down. Constant behavior is a horizontal line. Remember, a horizontal line is perfectly straight going left to right. So that would be a constant behavior of the graph, is the area between where it's horizontal. And a horizontal line could continue forever too. Maxima. These are points where the graph turns from increasing to decreasing, or the largest point of a graph. So if you have a graph that's curved, where it goes from increasing to decreasing, the top point of that graph, that would be a maxima point. All right, then we have minima. So same idea, where a graph turns from decreasing to increasing, or the smallest point of the graph. So if you have your curved graph, so here where it goes from decreasing to increasing, so the smallest or lowest point, or any of the low points anywhere where it curves, would be the minima of your graph. Okay, so we're just going to use those ideas in order to identify the key features of some graphs. All right, here is our first one. So on this graph, it's a V shape and it stops at these 2 points. If there were arrows, it would mean that our graph continues going. So we're going to start with the domain. Remember, that's the x value. So we have to look at the x-axis. Here's x, here's y. So the domain would be, well, our graph never gets bigger than this point and never gets smaller than this point because it falls in between. Oops. Okay, so that means x is going to be less than or equal to 3 and greater than or equal to -3 because it falls between. Anytime you have solid circles, it's or equal to. If it's an open circle, it would mean that it does not include that point. So it would strictly be greater than or less than. So the domain, it's x values, and it falls between -3 and +3. All right. The graph itself is always going to be greater than or equal to -3. So our x value is going to be greater than or equal to -3. And the graph, since it's between, it'll be less than or equal to 3. So x is less than or equal to 3. And I always read it from x when I'm reading it this way. And you do want to write it with the x value between the two numbers. Okay, range, that's y. Okay, we know that our graph stops. It doesn't continue going on. So it's going to fall between these y values. So it's always going to be between these. So y is going to be between, the largest it will ever get is up here where y is 2. Smallest will be where y is -4. All right. It doesn't matter which one you start with. So I'm just going to say down here at -4, I know the graph's always going to be bigger, larger than, or equal to it. It's a solid circle, so it has to be or equal to. So y is greater than or equal to -4. Up here, my graph never gets bigger than 2. It's always going to be, well, it's a solid circle, so less than or equal to 2. So y is less than or equal to 2. Okay, so x-intercepts. That's where your graph goes through the x-axis. So here's our x-axis. It goes through at this point, and it goes through at this point. All right, if you want to write the coordinates here so you can really look at them, well, the x value is 2, y value is 0. So that means one of the x-intercepts is 2, 0. The other one over here is -2, 0. So it's just the coordinate pairs at the points where your line crosses through the x-axis. And -2, 0. All right, y-intercept, same thing but y-axis. So looking at the y-axis, find the point where your line or graph goes through the y-axis. This is the point where x is 0, y is -4. So it just has one point on this graph where it crosses the y-axis. So we have 0, -4. All right, so now I'm going to look at increasing and decreasing behavior. I'm just going to look at my graph going left to right. And I'm just going to say, as I'm going left to right, it's going down here and it's going up here. Okay, so between these 2 points, it's going down. Between these 2 points, it's going up. So this would be our decreasing behavior. And we're looking at x. You're always going to use x. I'm going to start with decreasing because, well, that's first. So the x values fall between where x is -3 and it stops decreasing where x is 0. So it goes from -3 to 0. And these are solid circles, so it does include those points. So our graph is decreasing where x is -3 and larger. So x is greater than or equal to -3. And then the decreasing is where x is equal to 0 or smaller. So x is less than or equal to 0. So just looking at these values. So I'm basically looking at the x-axis. So where it falls, it would fall right between there. That's why where x is -3 and x is 0. All right, so increasing, looking at the same thing, it's increasing between these x values. So where x is 0 and x is +3. So x is greater than or equal to 0, less than or equal to +3 because it falls between them. So I always look at x, increasing behavior. And we said the smaller value is 0, larger value is 3. And it's where x is greater than or equal to 0 and less than, because it's between here, less than or equal to 3. Constant behavior, well, I don't have any horizontal lines on this, so there actually is none. So I'm just going to write none. Maxima, so our largest points. We actually have 2 maxima. Okay, so if my graph continued going up, they would not be considered maximas because the graph stops. They are maximas. So you're just going to write down the coordinates. This one, if you want to write it down on here, x is -3, y is +2. And another one, here x is +3 and y is +2. All right, then minima. So where the graph turns or the small values, the lowest values, lower values. So down here, it's actually the same as our y-intercept. That doesn't always happen, but occasionally it does. So it's the same coordinates because it's the lowest point. Is 0, -4. All right, let's try one more. I'll let you try a couple. All right, so this one's a little different. We have a flat line, horizontal line between 2 points, then it curves up, curves down, and then it continues going straight forever. So, starting with domain, we have our x-axis, y-axis. Domain is looking at the x values. So, looking at the x-axis, well, this is the smallest x will ever get. But as we keep going out, if this arrow continues going up, that means that the x values are going to continue this way forever. So that means that all the positive x values are included. But the smallest x will ever be is where x is -4. And it's a closed circle, so it does include the point, so it's or equal to. So x is greater than or equal to -4. All right, so then we're going to look at y for the range. All right, so our lowest y value is down here. So my graph's never going, I'm looking at the y-axis, so I'm kind of looking this way. What's happening to my graph? My graph's never going to go below this point. And I go up. Well, this part of the graph doesn't go higher, but this part does. I have to look at the entire thing. My graph's going to continue going up forever and ever and ever. So that means I just have to worry about what the lowest value is. That's where y is -3. My graph's always going to be larger, greater than, or equal to -3. So y is greater than or equal to -3. All right, now let's look at our intercepts. X-intercepts. So we have one here, and we have one here. So let's look at these coordinates. So on this one, the x value is about 1.5 or 1.5, and the y value is 0. Over here, the x value is 3, and the y value is 0. So on x-intercepts, if you noticed, your y value will always be 0 because the point where your line can go through the x-axis, y is always equal to 0 at that point. So we have 1.5, 0 and 3, 0. All right, y-intercepts. We have 1. This point, x is 0, y is 2. So y-intercepts are different where the x coordinate's always 0 because the y-axis goes through where x equals 0. So y-intercepts at 0, 2. All right, so this one's a little more confusing. Increasing behavior. All right, so I'm going to look at this going left to right. This one's flat, so that's not increasing. Oh, but here we're going up. Here it's going down, and I always go from left to right. And here we're going back up. So increasing behavior is between these 2 points. Again, I'm looking at x. X values are between -2 and 0. So x is between -2 and 0, and it's going to be greater than or equal to -2, less than or equal to 0. X is greater than or equal to -2. X is less than or equal to 0. All right, this one's going down, but this one's going up again. So that arrow means it continues going on forever. So I know that where it's increasing is where x is greater than or equal to 2. So we have an and where x is greater than or equal to 2 because it's going to keep going on. All right, then we're going to do decreasing behavior. So going down is between these x values, so where x is 0 and where x is 2. So x is greater than or equal to 0, x is less than or equal to 2 because it falls between. So I said the x value is between 0 and 2, and x is greater than or equal to 0, less than or equal to 2. All right, we do have a constant behavior on this one. We have a flat horizontal line right here. So it's between the x values of -4 and -2. So the constant behavior falls between -4 and -2. Well, x is greater than or equal to -4, less than or equal to -2. X is greater than or equal to -4, x is less than or equal to -2. If one of these had been an open circle, it would have been strictly greater than or less than. Because they're closed, they're both or equal to. All right, let's look at maxima and minima. So we have a maxima point right here because it goes from increasing to decreasing. And we already know the coordinate because it was a y-intercept. So we have a maxima at 0, 2. It will continue going up forever, so eventually these points will be larger, but this is still considered a maxima. It's called the local maxima instead of the absolute maxima because it keeps going up. All right, minima, well, this is flat, so that's not going to be included, but down here we have a minimum point where it curves from going decreasing to increasing. So the coordinates, x is 2, y is -3. So our minima is at 2, -3. Oops. All right, hopefully you're able to understand those. I'm going to give you 2 problems. All right, here's the first problem. You can pause it here, go through the answers, go through the problem. Then I'll give you the second problem in just a minute. All right, here's your second problem. Again, go through the problem, come back when you're ready for the answers. All right, let's do the first one together. The domain, x values. So here's x, here's y. All right, so the very smallest x value is where x is -2, and it's going to keep going up, so x is going to be greater than or equal to -2. Range, looking at y, this is the largest y value, and it's going to continue going down, so y is less than or equal to +1. All right, x-intercept. It goes through our x-axis about right here. So this is approximately, if your decimal's off by just a little bit, that'll be fine. So I'm going to say approximately -1.5. You might have said -1.4. Either work, because we're approximating because it's not perfect on this one, -0. -1.5, 0. And y-intercept. It goes through at 0, -2. All right, increasing behavior, there is none. Decreasing behavior, well, the whole thing goes down, so, and it's going to continue going down. So this is where x is less than or equal to -2. It's just going to keep going down as the x values whoops. I did that backwards because it's as the x values increase. So it's x is, I'm going to rewrite that, had my sign backwards, greater than or equal to -2. Because it's going to continue going down as the x values increase. It doesn't include any of the x values that are less than -2. All right, constant behavior. We don't have any horizontal lines, so there is none. Maxima, all right, this is our largest point, and this point is where x is -2, y is +1. Minima, we don't have any, because our graph's going to continue going down forever. That's what the arrow means. So you write none for that one. All right, last one. Domain, the x values. All right, so our graph's going to keep going down. As it goes down, it's going to continue going out. So it's actually infinite numbers. So it's going to continue going in both directions or all real numbers. Because you can say x is going to continue going to infinity, because remember domain is x, range is y, or I like to write all real numbers. All right, so range, y. Well, this is the top of our graph and it continues going down. So all these y values down here will be included. So that means y is less than or equal to positive 3 because less than makes it continues going down. X-intercepts, we have 2 of them. This one looks to be at about 1.5, 0. If you said maybe 1.4, 1.6, that's fine. So 1.5, 0. And this one looks to be over a little bit more. So I'd say negative 1.7 even, 0. As long as you are close to what I said, because it does look like it's not exactly halfway in between -1 and -2. Within a couple decimal points, I would accept. All right, y-intercept goes to the y-axis where x is 0, y is 3. All right, increasing behavior. So we are increasing and decreasing. So it's increasing where the x value is less than or equal to 0. Because all of this over here, because this is going to continue going down, so it will be increasing for all the values less than or equal to 0. Decreasing where x is greater than, wrote it backwards again, or equal to 0. Solid circle or equal to, it will continue going on. Constant behavior, none. Maxima is the very top point. We already know the coordinate, 0, 3. And the minima, there is none because it continues going down. All right, hopefully you were able to get those.